So for this trig identity, which side is the more complicated one? We want to prove it. I don't know. They both look equally, I guess, complicated. So I'm going to take a shot in the dark and begin with over here on the left-hand side and see where it goes. Okay, again, I'm working with, in the back of my head, knowing that I want to get this here. So all the steps I take, I want to kind of move them in that direction, whatever that may mean. So secant squared. That's going to be 1 over cos, and cosecant squared will be 1 over sine, and those are both squared. So left side is secant squared x plus cosecant squared x, which is the same as 1 over cos squared x plus 1 over sine squared x. Now remember, it's 1 squared here, but obviously the square of 1 is just 1, so I'm not going to bother to write it in. And I want to combine these together. Again, I want to try to get rid of this addition sign in here, so I just have, one term, because the right side, yes, only has one term. So what do? Well, this guy I'm going to multiply by sine squared x, top and bottom, times sine squared x, and here I'm going to multiply by cos squared x, top and bottom. And I will write my results down here. So I have sine squared x over sine squared x times cos squared x plus cos squared x all over same thing, sine squared x times cos squared x. And I can combine them together. I will get sine squared x plus cos squared x all over, and to save me some time, I will just copy this guy here and paste it all over that. And I think I can see where this is going. Again, from experience. If you don't yet, you will be very shortly. I'm going to have to use, though, this identity first. Okay, this is the Pythagorean identity. If you haven't noticed already, my numerator up here is also equal to 1. So I'm going to write equals 1 over, and I can paste this again, this denominator, which is equal to, if I separate this, 1 over sine squared x times 1 over cos squared x. Why am I doing that? Again, look up here. You're getting the product. You want to get the product of two trigonometric functions that are squared. And notice that these are the reciprocal ones, which, these are reciprocal. So let's do that. 1 over sine squared is cosecant squared x, and 1 over cos squared is secant squared x. And just to be, I guess, complete, I'll apply the commutative property, and I get secant squared x times cosecant squared x, which is equal to the right side. And that completes our proof.